knowledge-based system for programming industrial robots. Myself, Dadavali H, 8SEM C-section mechanical, and my USN 3BR 17ME 416. What is the concept? Shall we go to the next slide? What are the contents of my presentation? Introduction and interactive robot programming using mixed reality and concept overview and knowledge acquisition model and knowledge modeling model, knowledge processing model, and interactive robot programming the various capabilities, and last one is conclusion. Shall we now go the next slide? What is the introduction of my presentation? Robot programming is the desired motion so that the robot performs them without interruption. A major challenge for the use of industrial robots has been its programming, which requires expert knowledge. Offline programming tools based on simulation models are normally used to facilitate the robot programming. However, in many industrial applications, the intervention integrates the capability to run from manual adjustments conducted by operator. Based on the learned data, the KBS. What is KBS? Knowledge based system will be able to imitate the adjustment to the operator and enabling a full automation of the robot programming. Shall we go to the next slide? Okay. Interactive robot programming using mixed reality. What is the interactive robot programming? What is that using for mixed reality? What is the technology for use for in this presentation of the our robot programming? Okay, robots are often used to perform programmed tasks aimed at improving the efficiency and quality of the work, as well as replacing people in dangerous and boring tasks. The number of robots in industry is increasing every year. They are used to automate various processes. It is necessary to create a system for innovative and effective interaction between robot and human. The system for interactive programming of industrial robots based on mixed reality. My presentation is present by our robot programming is a knowledge based system. We can include our knowledge, the operator and robot. Okay. What is the concept of this presentation? Overview concept is based on the reversal approaches for the programming of industrial robots. Our work proposes a learning KBS system. What is KBS? Knowledge based system that additionally extend the system modeling to the interaction of new information provided by the operator. The various models deals with the collection of external information. Primary objective the KAM knowledge acquisition module. The next shall I next go to the next step? Next step, the gathered information of the KAM is integrated to the knowledge modeling model. The utilization of the information is handled by the knowledge processing model. Okay. What is the architecture knowledge based system with integration of expert knowledge? The figure shows manual adjustments and knowledge acquisition, knowledge modeling, knowledge processing, and knowledge base. This figure shows the structure of KM can be derived by looking a workflow of the correction of simulated robot program. This overall understanding purpose in three types mainly knowledge acquisition, knowledge modeling, knowledge processing, and knowledge modeling it include knowledge base. What are the two steps is there? What is the first step? The operator identifies a problem caused by error or incomplete of the system model. Okay, the operator corrects it by adjusting the poses and paths of the robot program and other system parameters. Okay, this is the architecture of the knowledge based system with integration of expert knowledge. What is the expert knowledge? We can adjustment of the learned adjustments of the knowing knowledge based system in which robot can work easily and efficiently. Okay, shall we go to the next step? Next slide. Okay, knowledge acquisition model. The figure shows manual adjustments and observation is there, and system information and implicit knowledge and implicit and knowledge modeling is there, and knowledge acquisition is there. What is the knowledge acquisition model? In there are two types of acquisition model. First one is acquisition of implicit knowledge. This submodel deals with the acquisition of implicit knowledge provided by the operator. Therefore, this model is responsible for converting implicit knowledge. The operator input feedback displaying a simulation into explicit information, machine readable form that can be processed by the KBS. What is the KBS? KBS is the knowledge based. Okay, next step, acquisition of explicit information. The second submodel is responsible for restricting the adjustments applied to the robotic system. These adjustments are usually more accessible and can be directly associated with the explicit information. For example, giant angles or velocity of the robots and process parameters and inner or inter alignments. Shall we go to the next slide? Knowledge modeling model. The figure shows knowledge acquisition, knowledge integration, knowledge base, and post and path panels, and knowledge processing. If the unprocessed information is connected with knowledge integration and knowledge processing, and it is include to knowledge modeling. Okay, what is the knowledge integration? The interpretation of the acquired information provided by the CAM is processed using rules such as description logics or the first order logic, and commonly used for classification and interpretation of information. Knowledge base. The achieve IE modular and flexible modeling of the robotic system. Our work uses a KB. What is KB? Knowledge based. Okay. The knowledge base is designed based on analytical model. Example, mathematical and probabilistic model and functions, and related models, and DL and feed FDL. Okay, DL means digital logic, FDL means first order logic, and data models and CAD, including CAD system parameters of the single components of the robotic system. Shall we go to the next slide? What is the post and path modeling? This figure shows a programming of the robot can work a programming by a analytic and kinematical mathematical models. Okay, the robot program defined the poses and paths generated during the offline programming normally has to be adjusted by the end user during the communication in the online programming phase. A robot post P is normally given by the spatial description of the end effector. What is the end effector? This is the robot part is the end effector. Position and orientation are the robot giant angles. The path is described by dynamics parameters normally given by the velocity and acceleration of the end effector or giant angles. Okay. This is the figure shows P the poses, U with the kinematic velocity, and V the velocity in which the program is connected to the robot. Robot can perform a work by a analytic and normally uh, analytical and normally works on a principal programming phase, online programming phase. The operator can explain by all things. Knowledge processing model. What is the knowledge processing model? Post models and unprocessed information is there, and pre-processing is there, learning model is there. The post models and unprocessed model is connected with a pre-processing in which the learning model, what is the program is converted into L is the pkz and pkz minus 1 and ykz minus 1. What is the p? The p is already knowing, p is the process. Okay, the workflow of the knowledge processing model. The model is responsible for the processing of the knowledge. The KPM is subdivided into two submodels. The processing model is responsible for filtering information that will be provided to the learning model. The learning model trains a model based on the given data with goal to reproduce a same adjustment to made to the system by the end user to correct a force or path. Interactive robot programming, the various capabilities. What are the capabilities is there? System description is there, system methodology is there, and geometric path modeling is there, path modification is there, and point to point with obstacle avoidance is there. Shall we go to the above slide? Okay, what is the system description? The figure shows Microsoft Woolens with connected with a computer, and the two companies is there, Kuka Alux and Kuka Aiwa is there. Okay, physical object and virtual object is there. Two object is there in which the MR glasses coolants is there. Two robots from Kuka company is there. Two robots controllers is there, and desktop computer is there. Direct Microsoft Woolens is direct computer connected with a computer. Computer is controlled by all robots thing by including a system description. This type of system description is there in robot technology and robot programming. System methodology. What is the methodology is there? Virtual tools is there, main menu is there, and pointer is there, and goal point giants information is there. We can see in giants, what are the giants? 7 giants is there. This is the degree of freedom is there, and human and virtual robot interaction with their tools, pointer, goal point, and giants is there. Okay, geometric path modeling. What is the geometric path modeling? Geometric means in which the geometrically tool will robot will travel a pointer and goal point and waiver points and all things, lines between and goal points and arc line. But the geometric arc line, and it is all type of geometric path. We can move the with the user point pointer robot. Path modification, the robot can path modification is there. Okay, point to point with collision avoidance and scaling, goal points setting, and path planning is there. Okay, what is the conclusion of our presentation? The fully automated programming of robotic systems remains an unsolved problem in many industrial applications where the robot programs are calculated based on models and mixed reality of robotic system which are incorrect or incomplete and cannot be updated. Finally, the KBM and mixed reality of robotic system is responsible to train a model based on the acquired knowledge to imitate the user handling for the adjusting robotic system. What is the reference is there? In all things are reference, and thank you for all.